My name is Samuel Gonzalez, and I'm a PhD candidate in the lab of Dr. Melissa Gardner at the University of Minnesota. My project aims at better understanding the importance of edge sites and EB1's ability to tip track growing microtubules. Previous work in our lab has demonstrated that EB1's on rate at edge sites is about 70-fold higher than at lattice sites. This led us to the question of if these edge sites are important in EB1's ability to tip track growing microtubules. To answer this, we created a stochastic model. In our model, EB1's on rate depends on whether the binding site is an edge site or a lattice site, and the off rate depends on the GTP state of the tubulin creating the binding site, and if it is an edge or lattice site. To date, our simulation has been able to properly recapitulate EB1 tip tracking of a growing microtubule. Furthermore, EB1's peak position behind the microtubule fitted end matches the acceptable range shown with literature values. Finally, decreasing the GTP hydrolysis rate in our model increases the EB1 comet length, which is also seen in the literature. Interestingly, when we removed edge binding from our model, EB1 no longer tipped tracked the growing microtubule end. Furthermore, when we try to increase the lattice on rate in the absence of edge binding, EB1 binds all along the microtubule rather than only at the growing end of the microtubule. Finally, we found that without edge binding, where the EB1 comet is along the microtubule is also does not match what is shown in the literature. This suggests that edge binding in our simulation plays an important role for proper EB1 tip tracking. To follow this up experimentally, we used a cell-free assay and examined MAL3, yeast EB1's, ability to tip track when there is competition for these edge sites with the drug erubulin. We found that as we increased erubulin concentration, there is reduced MAL3 at the microtubule end. This experimental work supports what was seen with our simulation, which demonstrates that edge binding is important for proper EB1 tip tracking. This leads us to our working model, where we do believe that EB1 can still bind to GTP lattice sites, like it's been shown in the literature, but we also believe that EB1 binds to GTP edge sites at a higher rate and is then locked in by the addition of new tubulin, leading to the accumulation of EB1 at the growing microtubule end. If you'd like to learn more, please come visit my poster during any of the 3 presentation time slots during the conference. Thanks for listening.